let's go over merge sort. So insertion sort and selection sort, like the actual code would be pretty straightforward, like you can kind of see how it's going to work. But for now, I'll just go over the algorithm for merge sort, and then we can go over the code after that. So for merge sort, what you're basically doing is you're splitting this array, whatever array you have. So let's just use the same array. You're splitting all this into individual groups one by one, and then you're merging all those arrays back together in order to get your sorted array. And this does take advantage of recursion in its actual code, but we can talk about that later. So first thing we do is we just split the array into two. And so since this has an odd number here, let's just make this side the bigger side. So we have 1, 5, 7, and then 3, 2, 9, 0. Okay. And then from here, we just split this again into two. And then we're keeping the bigger side on the right, so we have 1, and then 5 and 7. And then we have 3 and 2, and 9 and 0 in their little arrays. Okay, and then 1 is already split up, so that can just go straight down. And then 5 and 7, we're going to split it into individually 5 and 7. And then we have 3 and 2, and 9 and 0. Okay, now what we do is we work backwards. So let's just keep 1 the same here. Okay, now 5 and 7, what we want to do is we're basically, all of these arrays, they're sorted, because an array of one number is always sorted. It's just, that's the only position it can be in. And remember when we learned the two-pointer technique, we did a little bit of practice with sorted arrays and merging two sorted arrays. And what we did is, okay, we take advantage of the fact that two arrays are sorted, and all you have to do is keep track of one pointer for this array and one pointer for your second array, and then you compare the two numbers. So let's pretend that we had okay, so let's pretend we had that. Oh, sorry, the first array isn't sorted. What I'm doing. Okay. Let's do that. So these two arrays are already sorted. And what we would do is, okay, we compare the first two indexes, and we see, okay, we have 1 and 2, which one's smaller if we're sorting from smallest to largest? Okay, so sorry, first you have to create a larger array to store everything in at the end. And so that larger array would be size of this array plus this array, so just 8 for this one. And then what you do is you take the first two, the first index of the first one, and then the first index of the second one, and you just compare them. So let's compare 1 and 2. Okay, 1 is smaller. Okay, so now that we've already put 1 into the array, we only increased our pointer by 1 for this first array. And now we're comparing 4 and 2. Which one's smaller? 2. So we move our pointer over here. Now we're comparing 3 and 4. Which one's smaller? 3. So we move the pointer. 4 and 5. 4 is smaller. So then 5 and 7. 5 is smaller. And then 6 and 7. 6 is smaller. Okay, now here's the key thing here. You don't want to keep going on to the next index, like you don't have anything else to compare it to. But we can just take advantage of the fact that, okay, if all of these elements are smaller than 7, then we know they're going to be smaller than the rest of them anyway. And the rest of the array is already sorted. So basically, you just take advantage of the fact that these two arrays are sorted, and then you're basically just comparing the individual elements, and then if it's smaller, you just put it into the new array and then move up by one and then compare the next two. And you just keep going like that until you get to the end of one of the arrays. And then at that point, you can just put whatever's left of the remaining array because it's already sorted. You can just put it into the new array. And then you'll have a sorted array. So we take advantage of that here. Let's merge 5 and 7. So our final array will be of size 2. And then we're comparing index 1 to index 1. 5 is smaller. Okay, we're done with that array. We can just put 7 in. Okay, now 3 and 2. 2 is smaller. Done with that array. Put 3 in. 9 and 0. 0 is smaller. Done with that array. Put 9 in. Okay, now let's merge these two. 1 and then 5 and 7. So our final array will be of size 3. So we start with the first indexes of each array. Compare 1 and 5. 1 is smaller. Done with that array, so we just put 5 and 7 in. Now we're merging these two. Final array is of size 4. So let's compare the first two indexes. 0 is smaller. Let's move on to comparing 2 and 9. 2 is smaller. Move on to comparing 3 and 9. 3 is smaller. Okay, we're done with this array. Let's just put 9 in. Okay, now we just have to do our last step and see that these arrays are already sorted. So you can just do the same thing. Final array is of size 7. Okay, so compare the first two indexes. 0 is smaller, move on to 2. 1 is smaller, move on to 5. 2 and 5, 2 is smaller, move on to 3. 3 and 5, 3 is smaller, move on to 9. 5 and 9, 5 is smaller. 7 and 9, 7 is smaller. Done with this array, so then we just put 9 in. And then finally, we have our sorted array for merge.